Is it visible? Hello, hello. Is this visible?
Yes, sir.
Okay, so good morning, everyone. Last day I've discussed about the different data transfer techniques. So in that data transfer technique methods, one method was handshake data transfer using handshake signals. Okay, so what is it? What is the mode and how it works? That will be discussed today's lecture. So these handshake signals, this is basically are used to transfer the data transfer data with the help of programmable devices. Okay, so why it is needed? These handshake signals. Uh, Actually, the microprocessor and the peripherals operate at different speeds. Therefore, signals are exchanged prior to data transfer between the fast responding microprocessor and the slow responding peripherals, such as printers or data converters. Now, these signals are called handshake signals. Okay, this exchange of handshake signals actually prevents the microprocessor from writing over the previous data before a peripheral has had a chance to accept it, or from reading the same data before a peripheral has a time to send the next data byte. Okay, and these signals are generally provided by programmable devices. So here is the diagram. So it shows a programmable device in the input mode with two handshake signals. One is called strobe STB, another is IBF, and one interrupt signal which is INTR. Now, the microprocessor has two ways of finding out whether uh, a peripheral is ready or not, either by checking the status of handshake signals or through the interrupt technique. Okay, so I will discuss about the interrupt technique uh, with this context. So what happened in the input mode? Suppose this is the microprocessor, this is the programmable device, and this is the input device. Assume this is keyboard. Okay, now when a key is pressed, how that key is identified by a microprocessor, how this microprocessor reads the particular switch on that keyboard. Now a peripheral here, it strobes or places a data byte in the input port and informs the interfacing device by sending handshake signal STB strobe. The device informs the peripheral that it is the input port, its input port is full. Do not send the next data byte until this one has been read. Okay, and this message is conveyed to the peripheral by sending uh, handshake signal IBF, input buffer full. Next, the microprocessor keeps checking the status until a byte is available, or uh, the interfacing device informs the microprocessor by sending an interrupt signal that it has a byte to be read. Okay, next the microprocessor reads the data byte by sending the control signal read bar, and with this data bus it is read from this device. Okay, so there are two handshake signals in this input mode. One is called strobe, another is input buffer full. Now this is the diagram when any output device is to be connected, and what are the handshake signals in that in this mode? Suppose this is the processor, this is the programmable interfacing device, and this is the printer or output device. Now, one thing you have to remember, that if you want to connect any input output device with our real world system, then you have to connect it via interfacing device. You don't connect it directly with the processor. Suppose if you want to connect any switch with the processor, so you can't connect it directly, that you buy a switch from the market and it connects to the microprocessor IC. No. Okay, you have to connect it via interfacing device. There are lots of devices, I will be explained in later lecture. So one programmable interfacing device is this one, assume. So when this printer is to be connected via this programmable interfacing device with the processor, now how the handshake signals works with this uh, output mode. So first microprocessor writes the data byte into the output port of this programmable device by sending the control signal right bar. Next, this device informs the peripheral by sending handshake signal output buffer full, that a byte is on the way and you have to accept it. Okay, now the peripheral acknowledges the byte by sending back the acknowledge signal ACK to the device. Okay, then device this device interrupts the microprocessor to ask for the next byte, or microprocessor uh, finds out that the byte has been acknowledged through the status check. Okay, so here handshake signals uh, acknowledge and strobe. This acknowledge and this strobe are input signals to the device and perform similar functions, although they are called by different names. In the same way, handshake signal um, input buffer full and output buffer full, these are output signals from the device and perform similar function, that its buffer is full. Okay, so these four handshake signals are required if you want to connect such programmable interfacing device, and one such programmable device is available as 8255 programmable peripheral interface. Okay, programmable peripheral interface. Is it clear? Any question? Handshake signals? Any doubt? Any doubt regarding the handshake signals? Programmable devices with handshake signals? In this topic, do you have any question? You can ask me now.
No, sir. No, sir.
Then proceed to the next topic, which is 8255 PPI, programmable peripheral interface. This is very important in every microprocessor, because that is the uh, device always you need to use in your uh, interfacing program. If you want to connect any switches with the microprocessor, if you want to connect any stepper motor to run it at different speeds in a different position, clockwise or anti-clockwise, if you want to connect some 7 segment LEDs, so display, you need to connect it via 8255 programmable peripheral interface. Okay, or in short it is called PPI, programmable peripheral interface. So it is an IC. Okay, wait a minute. Is it visible?
Yes, sir.
Okay, so Intel 8255 programmable peripheral interface, why it is needed? Because it can be used to transfer data between external device such as input and output device through different ports with the 8085 microprocessor. Okay, normally a register can access an IO port. Uh, However, using a separate register and configuring it for input and output operations is very difficult for us. Okay, so Intel has designed a separate IC which is called 8255, and the aim of this invention or design is to interface the input output device with the Intel microprocessors. Okay, so 8255, it is used with a wide range of input output cards that plug into the available slots in a PC. Okay, the 8255 programmable peripheral interface, that is a very popular and versatile device IC that can be easily programmed to function in different configurations. There are lots of modes are available, so according to your requirement you can select that mode and perform a specific function. Now the this chip can perform digital input and output from the processor in a programmed manner, and the common applications are to sense a switch or to control the movement of different motors, DC motors, stepper motor, and detect the position. Okay, next, the different features are available in 8255. So it has actually it has three TTL compatible registers or ports which allow programmers to control digital outputs, inputs, or a combination of both. Okay, so it has three 8-bit ports A, B, and C that is connected to the output pin. Okay, port A, that is 8-bit in size, port B, that is 8-bit in size, and also port C, that is 8-bit in size. Now, port C, that is again divided into two groups, 4 bits each, like port C upper and port C lower, PCU and PCL, and each of them that can be programmed independently or as 4-bit ports for input and output operations. Now, all the ports that can be programmed for simple input output or handshake input output in the IO mode. Okay, just I have discussed about the handshake signals. So those handshake signals can be connected via these ports, which are available in 8255 PPI. And each port C, only port C, that can be set or reset individually in a mode which is called BSR mode. There are two modes primarily in 8255. One is the simple IO mode and BSR mode. IO mode and BSR mode. Only IO mode, in IO mode, port A, port B, port C, all ports can be used. But in BSR mode, BSR means bit set reset mode. In BSR mode, only port C is available. Port A and port B cannot be used. So port A bits and port C upper, the bits of port A and port C upper, these are grouped as group A, and the bits of port B and port C lower are grouped as group B. Now this is the block diagram of Intel 8255 PPI. Okay, it's a programmable peripheral device. It's not a microprocessor, neither a microprocessor nor a microcontroller. It's a programmable peripheral device through which different peripherals can be interfaced. Okay, so here is the block diagram where A, B, and C uh, ports are grouped into uh, group A and group B. In addition, there is another register called control register. There is another register called control register, and the contents written into this control register decide the operating modes of the three parallel ports. Okay, now to identify the, so here in this block diagram you can see it, that data buses. So assume here is your microprocessor on the extreme left hand side, and these are the connections that can be made to connect that 8085 microprocessor. Now microprocessor database data bus, 8-bit data buses are connected through these data buses of 8255 PPI, through which the data can be transferred. And microprocessor control signal, read control signal can be connected over there, write control signal can be connected over there, and microprocessor two address lines A0 and A1, only two address lines will be connected to these two address lines of 8255 PPI, and microprocessor reset signal is to be connected over there if it needs to be reset. And every IC, whether it's a memory device or IO device, every IC has its own signal to activate, and that is called the chip select signal, which is over here. CS bar, it is active low signal. So to work with this IC, it is an IC. To work with this IC, you need to first select the or you need to enable this IC first, then perform the required number of operations. Okay, so it is a 40 pin IC. Okay, and now the different three ports are grouped into in this way, that is group A, which is port A, 8-bit in size, that is PA0, PA1, PA2, PA3, PA4, up to all the way up to PA7. All 8 bits can be connected to the input output devices. Okay, and group B, under group B, so under group A, port A is available and port C upper is available. Upper means PC4, bit number PC4, bit number PC5, bit number PC6, and bit number PC7. So 8 plus 4, these 12 bits, these 12 bits are available as your group A control. And under group B control, two ports are available: port B 8-bit in size and port C lower 4-bit in size. So another 12 bits are available under group B control. Okay, so total 24 IO pins are available: 8, 8, and 8. Port A 8-bit, port B 8-bit, and port C 8-bit. So total 24 IO pins that can be grouped primarily into 8-bit parallel ports A and B, and these can be used to connect any IO device. Now to identify the four registers, the 8255 uses two address lines, A0 and A1. A0 and A1. Now these lines get their signals from the 8085, as I have told you earlier. Uh, 8085 address bus A0 and A1 of 8085 is to be directly connected with the A0 and A1 line of 8255 PPI. And if both lines, if both address bits are 00, in that case, only port A will be selected. If A0 line is 1 but A1 line is 0, only port B will be selected. And if A0 is 0 and A1 is 1, only port C will be selected. And if both are 1 1, control register will be selected. Okay, so in this way different registers can be selected with the help of two address lines A0 and A1. Now here's the pin details of 8255 PPI, where 40 pin, it's a 40 pin IC, and I have told you all these pins functions. Next, coming to the operating modes. So the functions of each port in the 8255 is software programmed by the programmer. Now this is done by writing a control word in its control register. So control register, that is 8-bit in size, and control word, that will be stored inside the control register. Now to perform any function, before starting your operation through 8255, you have to load the control word into control register, so that microprocessor can identify, okay, this port is used as your input port, now this port can be used as your output port, or this mode has been selected. So everything will be given inside that control word, because each bit in that control word, it specified it specifies the different functions. Okay, so I will discuss it later, the control word of each mode. Now there are two operating modes. Mm, one is the IO mode, another is the bit set reset mode. Now in IO mode, there are three modes for the ports. Mode 0, which is called the basic IO mode, where A, B, C, all three ports are available. And mode 1, that is called handshake IO mode, on, applicable to only group A and group B control. And mode 2, that is called the bidirectional input output mode, which is applicable to group A only. Okay, group B is not used under this mode. Okay, so the programmer can select a particular operating mode using the commands and the control words. So here the three ports of the 8255, these are grouped as group A and group B. So group A and group B accept commands from the read write control logic, receive the control words from the internal data bus, and issue commands to the associated ports. Another mode is available as BSR mode, which where only port C is applicable, port A and port B is not required. And this chip has to be programmed to configure its operation before using it every time. Okay, and the configuration, that is to be done by that is done by the control word, which tells the 8255 whether the ports are input, output, bidirectional or strobed input. Everything that will be defined in the specific control word. Okay, so tell me, clear up to this much? Do you have any queries, any doubt? Any queries, any doubt regarding the 8255 operating modes until now, which I have discussed? The features, what is the function, how it works, or what is the requirement to use this? Do you have any question regarding this?